Now let's understand what is mean by mean. Everyone know what is mean by mean? Nothing but average. Yes, average set of numbers. What is the average set of numbers is sum of all value divided by the total number of value. That is how we get the mean. Okay, so the mean is an arithmetic average of set of numbers which we calculate by summing all the values of the data set point and then dividing the total number of data points. That is the mean. When to use and why to use. The mean is most appropriate when dealing with interval or ratio data, where the data points are numerical and evenly spaced. It is sensitive to extreme value. I'll tell you what is meant by extreme value. So it may not be the best measure for the central tendency when the data contains outlier or say, okay, just ignore the second point, which is very difficult to understand at this moment or at this point of time. Those who having office and all, guys, you can leave. Anyways, this recording will get uploaded in your LMS. Okay, don't worry about it. And maximum about 10. Okay, if you wanted to continue, you can, or else you can leave. Okay. Now, what is mean by mean? We understood this. When to use that? Whenever we have interval or ratio, whenever we are dealing with the ratio or interval data type at the time, we can just use the numerical data type as a mean. Okay. Now, it is very sensitive to extreme value. What is meant by this extreme value and outlier is, I'll just quickly give you example and then I'll exclude, okay, can anyone?
So your voice is breaking.
You're on mute actually.
Yeah, because there is some background noise. I'm just waiting to them, it will get stop. I'll unmute myself. Just about extreme value. Can anyone tell me, is there any extreme value you are able to see in the cell number 22?
Yes, 80.
80 is the extreme value where we normally call it as what, guys? Outlier. Okay, why outlier? Any extreme maximum value and any extreme minimum value. How to decide that? Because if
Because
you
for
see,
that particular values, you can see the mean is getting shifted to rightwards.
correct. So the range of the data is about, 1 to 8. But the 80 is what the extreme value. If you are taking the mean, if you are taking the average of this list of numbers, you'll get 15. Okay. But if you are taking mean for this, it's just 4.5. Why is that so? Because that extreme value was that 80, what it just shifted to the what rightmost. Why? Because it is anyways, it will affect to the average of your whole data set. Understood the point which has here written here? It is mean is sensitive to extreme value, which is outline. So it may not be the best measure of central tendency when the dataset contains outlier that significantly affect the average. Understood? I have just given
Yes.
you practical example of that, nothing else. Why and how? Okay. So what is measure of central tendency is mean. That is the mean. Okay, because whenever you have a your data is uniform in nature or it is distributed equally the both side of your mean, we call it as what? Bell shape curve. We call it as what? Your data is what? Normally distributed data, or your data is what? Uniform data, where distribution of data is equal to both the side of your mean. Okay, so if it outlier present in your data, it may be get shifted, or it may be get influenced by the outlier. Understood, everyone?
Yes.
Good. Now we have a median. What is meant by median? Middlemost value. Okay. The middlemost value is the data set when the value is arranged in ascending or descending order. Always keep it in mind whenever you are going for finding mean, you need to sort your data first. It should be ascending or descending, and then after you can go for finding the median of your data. Got it? When to use the median is robust to the outlier. Okay, because if you are going for mean, anyways outlier will get at the starting or the at the ending of our list. Okay, so outlier ka kuch it will not get influenced by. It is particularly useful or the ordinal or the skew distributions. Just keep this some new terms at the beginning of this your class. It will get elaborate in depth. Just your classes will get started. Don't worry about it. I'll give you the basic idea what exactly I mean by skew distribution, what is meant by. Okay, where the mean may not be accurately represent the central of data. Yes, correct. In situation where there are extreme value, which is nothing but outlier, or the distribution is not symmetrical, where if your data is not symmetrical, the median provides a more representative measure of central tendency. That is the correct one. Okay. Whenever our data is not symmetrical, that I have told you, which is if in case our data is not uniformly distributed. Okay, so median provides more representative measure. We understand mean, we understand median. Now we'll understand mode. The mode is what? The mode is the value that appear more frequently in dataset. It will return us the most frequent appearing dataset. When to use mode? Mode is very much suitable for the nominal data where the values are categorical. Guys, median and mean we normally use for the numerical data. We use mode for the categorical data most of the time. Okay. It is used for identifying the most common category or the value in the data set. Correct. In case where the data set has multiple modes, of course, if you have a binomial, trinomial, etc., the mode may not be the informating determination of the central tendency as the mean or the median. But most of the time, we'll go for the mode whenever we have a categorical data. Okay. Now my question is, where the median is, like if we having odd number of data like this, like 4 and 4. Can anyone tell me what is the number of median?
5.
We cannot use here, na? It should be either in ascending or descending, na? For median.
For now, just forget that sorting thing. Could you please tell me what is the median?
Then it will be 5, as
5.
someone
Five.
said.
Five.
Okay. What is the median now?
4.
4.5.
In previous slide we saw the middle. If it is even number, if the number of set is even, then it will be the average of two middle values.
Very good. Whenever we have even number of set of data, we need to addition of the both the middlemost value and divided by 2. Okay, so the here median is 4.5. Good. Now we understood mean, median, and mode. Okay, which is we understand the measure of central tendency. These all are measure of central tendency, guys. Mean, median, and mode. We have a we that means we have a central of tendency. Now we are going to understand measure of desperation. Before that, we'll take a 5 minutes of break. Now it is 9:30. We'll come back at 9:35. Is okay for all, and then
Sure,
we'll
ma'am.
continue. Yeah, thank you.
Thank you.
Check what are the measure of dispersion. What is meant by dispersion? Any idea? We'll check what are the measure of dispersion. What is meant by dispersion? Any idea?
Scattered data.
Very good. Scatter data. Dispersion is nothing but scatter. So we need to check how your data is scattered on a scale. Okay. So whenever we go for the analysis, guys, we can't go or we can't take the data as it is. If it is dispersed or it is scattered a lot, we need to compress the data on a particular scale and then we need to go for the further analysis. That is the first point. Now, if I'm saying that, how to check the measure of dispersion, how to check the measure of spread, there are some measures they have mentioned in statistics that we need to study. The first is variance, the second one is standard deviation, and the range and the interquartile range. What is meant by variance is nothing but it is the average square of difference from the mean. Okay. We all know what is mean by mean. Mean is nothing but the total of the all data point divided by the total number of data point. Okay, which is your mean. Now, whenever we are talking about variance, it will take a difference or the distance between the data point and the mean, and it will square the difference. Got it? If you square the difference, you'll get how exactly your that particular data point is dispersed or spread from the mean. That is the first. The second one is was on mute. Okay. The second one is standard deviation. The standard deviation is nothing but the square root of your variance. You all one is square standard deviation. The standard deviation is nothing but what? The square root of your variance. We all know the variance is what? The difference between mean and the data point. We are taking the square of it. Okay. And the standard deviation is what? It is square root of your variance, which provides the major or the which provides the average distance of each observation of your mean from the mean. Distance of each point or observation from the mean. What is the range? Range is nothing but simple, the difference between maximum number and the minimum value in the data set. That is what range. What is interquartile? The range between the first quartile. The first is always 25 percentile. The third is 75. And the middlemost is what? 50 percentage of your data. Okay, just mention this one only. Now, what is the formula? Anyone having any doubt?
Ma'am, can you please repeat the variance part?
Variance. Okay. Okay. This is the mean of my data set. Okay. These are the data point. If you wanted to check the variance, what exactly the formula is? The formula is the average of the square difference from the mean. Whatever is your mean, let's say 4.5 is your mean. Okay. It will take the difference between what? The difference between the data point and the mean. If I wanted to check the variance for this is what? The difference between the data point, mean and data point. Now, how to take? This is the formula. This is the formula where what it is saying, xi is nothing but this data point, 8, okay, minus 8 minus what? Mean. What is mean? Mean is nothing but 4.5. Okay. What is the 4.5? The whole square divided by n minus 1. N minus 1 is what? It's just a sample. The number of record divided, the number of record minus 9. If you have 10, we have to take a 9. Now, if you are, solving this thing, you'll get the answer. That is nothing but variance. Now understood? Why this summation? Because summation is what? Because we are taking the variance for each data type. No? So whatever answer it will get added to the next number. The next number is again, the next number is, let's say this one is 9. So again it is 9 minus 4.5. 4.5 is nothing but your mean. The whole square, and again that number will get added to the this one. So that's the reason we are getting the summation of all the data point. The difference between mean and the point divided by 9. Now understood?
Yeah. Thanks.
Now what is this percentile is? Percentiles we normally use for outlier, guys. Don't take now onwards. Abhi, whatever I'm going to discuss, just listen to me. Anyways, this is going to be covered again in at the starting of your Python. Okay. Percentile quartile is what? It's just a thing where how your data is distributed. Okay. So is it in 25 quartile? That means your first quartile is your second quartile, or is it in third quartile? So first quartile is your 25% of data. In 50% of data, you're having the second quartile, and the 75% at the end. Got it? Why we are doing this? Because if my data is, if let's say I'm having data, and if I'm getting this type of graph after, after checking the dispersion of my data, so then I can say most of my data is distributed in the Q1, that is second quartile of my data. Understood? Skewness, which I have just, we have read this term at the, at the beginning of our PPT. What is meant by skewness? Skewness is whenever we have, okay, this is what symmetrical data. This is bell curve. This is symmetrical data. Whenever we are not having symmetrical data, that means what? The curve may have a tail at right side or the left side. Okay, this is the case where if we have asymmetric data, that we call it as what? Skewness. The skewness is what? The probability of the distribution of a real value, that is random variable, is it's about its mean. Okay. Now if there is a tail at your left hand side, we can call it as what? Negative scale or negative skewness. If your tail is at the right hand side, we can call it as what? Positive skewness. Why to do this? Whenever we wanted to check the risk in your business, then at that moment, we can measure the skewness of your data. Is it right tail? Is it negative or is it positive? Okay. Kurtosis is same. What is the kurtosis? It will check the right tail. Is it negative or is it positive? Okay. Kurtosis is same. What is the kurtosis? It will check the peak. If you are able to see, the distribution may be in purple line, distribution of your data may be in blue line, or distribution of your data may be in green line. What is that? Nothing but the probability of distribution of your real value of the random variable. Okay. Now, again, it will tell you what is the probability of your business is positive, negative. Okay. What is the now how this kurtosis will indicate or will show us the positiveness? The positive kurtosis will tell us the heavy tails. Heavy tails matlab the tail which is, sprayed along with the major. Got it? The negative kurtosis indicate the right tails that we already see. Okay. And the zero kurtosis where we have a similar distribution. That is the normal distribution. If you say this blue one, sorry, this green one, that is mesokurtosis distribution is your normal distribution. Okay. This peak of your both the graph, blue and purple. Okay. These are what? These are the kurtosis where we have risk.
Can you give any practical example of where we would be using all of this, like variance, kurtosis, whatever you have mentioned till now? Hello.
Vaishnavi,
Yeah,
it is quite difficult to, practical example, give you practical example because if it is
because I'm unable to relate, like where would we would be using all of this.
okay, for example, I'm just giving you, okay, try to connect with me. Now, see, this is the data we have. Let's consider that, okay. Okay. Now, this is the graph. Can you can you tell me is my data is normally distributed or not? Let's increase the number of data point. Okay. Now this black line will tell you how far the variance of your data. Okay. Now see, this is the mean of your data. If you draw, see, this is the way you'll get the graph. Understood? If you could have like graph like this, you may get this type of graph. Understood? If in case this mean is not normally distributed, so in that scenario, you may have this type of graph. Understood, Vaishnavi, now? Not yet?
Kind of.
Yes, Vaishnavi?
Can you please repeat
Yeah.
once?
Sorry, not able to, you're not audible.
Please repeat.
Guys, you're not audible to me clearly what exactly you said.
Can you please repeat once?
Okay. This is nothing but what, guys? Distribution of data. See, whenever your doubt is when to use what, and when you are not having clear picture what exactly you are, when you are going to understand these things is because this thing is the whenever you are going to start with the data now. Once you have data and if you draw something like this, then you, on the basis of that you can just draw your scale or draw your graph like this, and you can check the distribution of data. That means for dispersion of your data. Once you have idea on dispersion of data, then on the basis of that you can take decisions. For example, uh, if you have a business risk on this type of decisions you can take. Anyways, you need to have a graph. Whenever this is my data, guys. See, this is my data. Can we just looking at data, can we understand how my data is distributed? No, we need to have some graphical distribution or graphical a graphical help. So there are some libraries we do have. Okay, with the help of that we are going to take a graph, and then we can check what is the distribution. Now my graph is normally distributed, now my data is normally distributed. So in this scenario I'm not getting to see any of this type of graph. Okay, this type of graph, my right now I'm having measure kurtosis distribution, which is normal distribution. Whenever you're having middle most mean, and all your data point are around your mean only, it is not far away from your mean at that moment. If in case you're having very random and very extreme values in your data point, in that scenario you'll get the second one, that is platycortosis. Understood now? Don't worry. See, this is histogram. Now can anyone tell me, is your normal distributed? Is this graph is normally distributed? Yes or no? Looking at the graph, you can tell me, is your graph is skew or not distributed? At least tell me that.
No, I think
No, what, Saroj?
like distribution not as well like normal distribution.
Very good. It is skewed. Can you please specifically tell me, is it right or left?
It's towards right
Um,
mostly
it
because
is left now. भाई देखो,
right, right. Okay.
हो गया खत्म यहाँ पे, राइट में जा
Yeah,
कहाँ
right.
रहा है?
Yeah, so left.
It is left. It is negative skewness.
Yeah.
Understood? Now, if you could have like this graph, अगर आपका graph ऐसे कुछ होता, तो can we say it is normally distributed?
Yeah, because both side will be like
Yes.
equal, right?
Correct, 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 correct. Now understood, Vaishnavi? ओके. नॉर्मल डिस्ट्रीब्यूशन कैसे होता है? ये नॉर्मल डिस्ट्रीब्यूशन ऐसे होता है जहां पे टेल मीन एट द मिडल मोस्ट होता है. एवरीथिंग विल बी like you are getting bell curve. Now why this they have given, they are saying here in first graph 60%, 68%, if in case if you have histogram like this. Okay, and if you draw the bell curve on the your histogram, if you are getting like this, so 68% of your data or the value within the first standard deviation of your mean. Understood? That means what? Every point of your data point is around your mean. It is not scattered, it is not at all dispersed from your mean. That is the first one. The second one is the 0, -1, +1. These all are standard deviation, guys. First standard deviation, second standard deviation, third standard deviation. What is the range of standard deviation is? -3 to +3. Whenever your data is in -1 and +1, we are saying that only first standard deviation. It includes -1 and +1 both. If you again this type of graph, you can say your 95% of data is within the second deviation because the range is -1 to +1. Understood? And if in case you are having this type of graph, you can say the standard deviation of your graph is what? What is the range? 3. within third standard deviation of your mean values. Understood? Skewness का तो हो गया है. What is mean binomial? Binomial distribution where we have two distinct peak in the distribution. Yeah, it may be the chance that